Everyone, I'm happy to give you another presentation. It should be lecture 7. I will discuss the client-side distributed primitive API. I have already introduced about nine APIs on the server side in the previous classes. So today I will talk about the client side. Client side is easy. Think a client side just need to send messages and get the response. It does not, the client side the client side does not need to deal with potential incoming large high volume messages. So just send a request and send a notification. So just one. Sometimes it's the API. We need to provide an API to send a message to the server in a synchronous manner. For such API, it's a little bit difficult to design. But so for other cases, for example, send to the server notification asynchronously and send a request to the server and get a response from the server. For such two cases, the API is easy to design. So the client side is not so difficult to be implemented if you want to do some to design distributed system but I think that I have to provide a simplified and easy to be used APIs. So I also I think at this time I think the version of this kind of version maybe convenient after a lot of experiments and testing and in practical implementation. So it's just I can start here. The first one is a sync remote eventer. Sync stands for synchronous. That means we'll send a notification. In a eventer means we send a notification, right? Remote means there are two different some interaction is performed between two distributed or multiple two distributed nodes over the network. So sync means when we send, if the notification is not finished to be sent, these statements should be blocked. So it's a blocking operation or blocking statement. I think everybody who know concurrency programming should understand what is blocking, right? Method or blocking statement. This is a class of the remote eventer, remote eventer. It should be easy, right? We just need to specify the placeholder notification. No parent, no interface to be implemented. Constructor. For the we need to for this constructor we need to have a initiator, and we had to have a parameter. The parameter is we call it a free client pool. Free client pool. You can see here, free client pool, right? Free client pool is a free client. This is also a API I created, but I think it's not a distributed primitive API. I think it's for example, it's a I have some APIs. I do not include them in the distributed primitives. It's just like some additional ones. It's just a helper classes. It's not the primary distributed primitive APIs. You can see some such APIs in the later time, but it doesn't matter. I think it's not so important. Free API for free client API is this free client pool is used to manage the TCP client. You just understand. If you know that, that's enough. So because we need a lot of computing resources should be managed, even at a client side. Although client side is simple, we should. There's still some other important computer resources should be managed. So this pool is designed by me to do that. And I think it's a little bit implementation effort if you have to use Java Standard Edition or use Python or use C to do that. In using, it's a little bit difficult, right? So I have done that for you, so you don't need to spend any effort on that. So this is a one unique parameter to initialize the sync remote eventer. The method is also simple. Dispose. We need to collect all the resources. But the primary resource is the TCP client, and we also need another method is we use a lot. It should be the notify, right? We need to tell the server, tell the parameter is the IP address, and the port number, and then we need to notify the message notification, right? Notification is sent by the specific notification implementation is another implementation parameter of the method. So it's very easy. We take a look at the code here, the real code. Open this project. We can take a look at here. A lot of code, right? A lot of code. If you can download all the code from the GitHub. We focus on this one. To node. If you want to find the retrieve all the code, find the real code, you can follow this video. And now we focus on, and according to the name of the packages, you can find what according to the name you can know, find the URL. You can understand the package name, and will tell you where we can find the primary contents, the primary target, the primary sample. You can get to know what is it talking about according to the package name, right? Package name, right? So here if you open this one, no, not this one. Start. You can see here. Start means there is a main method included in this code. Usually I name it start, right? But you can see here, there's the same that there are no synchronous remote eventer, right? But here, if you open this one, chat eventer. Oh, in this case, I use a synchronous remote eventer. And I will try to find another one for you. If you go here, this is the server, right? This is server. You can also find the client. Here is the client, right? Synchronous remote eventer. You can get it from here. This is the package name. So you can find almost everything easily according to the package name. This is a implementation, underlying code, implementation of the synchronous remote eventer. But now I'm trying to teach you how to use it, so you don't need to worry about internal implementation. If you're interested, you can take a look at this. But at this time, We don't need to worry about that. You can see the most important API or field attribute is the free client pool, right? So let us focus on how to use it. Maybe this is the case how to use it. This sample code will show how we can use this this API. Here there is we implement a class called business eventer, and he use this API sync remote eventer, and this is the generics. There is a message that should be sent by synchronous remote eventer. And this is called notification. And here, this is the singleton implementation. Here, we need to create a new instance. The client pool is this one, right? Client pool is a free client pool. So if we create it here, then this is easy to be created, right? This is how we can create a client pool. And if we want to send a notification, we will need to specify the code, right? We specify the IP address, the port number. Both of them are in the format of constants. In the form of constants, this is the notification to be sent. So it's easy to be used, right? This is a simple API. Next, we can take another one, asynchronous remote eventer. Asynchronous remote eventer is used to send a notification in a asynchronous manner rather than synchronous one. So it's for this method is of these statements that use this method use this eventer API to send a notification. The method is a non-blocking one because it's a send notification in a synchronous manner. So it's a non-blocking method. Non-blocking method means that even the notification is not sent, the notification is saved to a queue, but it's not finished to be sent to the remote server. But you can do something else at a client side. You don't need to worry about whether the notification is already sent or not. It will in some cases, if you don't need to, there are no synchronization management. You don't need to worry about the synchronous issue between the server and the client. Then you just leave the message there and do something else. So this sometimes we need such a API to do something asynchronously. This is a class. The class is also simple. There is an API should be implemented. Interface should be implemented called check addable. This API also implemented by me. It used to do something to monitor the thread because of some asynchronous processing on the line. So some thread should be managed. The check addable interface is used by the system to manage the underlying mechanism to manage all the invisible thread for you. So you need to implement such an interface. No, you don't need to worry about that. I implement. So you just use this method, this API. The parent, we can take a look at here. It's a thread. It's itself is a thread. Notification placeholder. We can take a look at this actual code, right? Okay, this is implementation. This is the implementation. This implementation is compared with the synchronous remote eventer. This implementation is complete, right? It's a little bit complete because the primary effort is focused on how to manage the threads, how to manage all the threads. So this is the implementation. If you are interested, you can modify it, right? But in this class, we do not talk about this issue, right? So this this is the class, a little bit difficult, right? Constructor. Some parameters need to be used to initialize one instance of a synchronous remote eventer. It looks less compared with the synchronous remote eventer. It looks more complicated. You can see there are a lot of parameters should be used, but similar to the previous classes, we do not spend much time on that. So you can see some the queue, wait time, wait, run, idle check. You must have seen something similar stuff in the previous classes, right? If you're interested, you can read the details. But at this time, because I want to teach you how to program the code, and so all the parameters, you just use the constants first. At first, you just use constant on your PC, on your servers. So you don't need to worry about that in detail. I think if you are experienced engineer, according to the name, you must know something about that. Because the name must make sense, right? If you are confused, you just can interact with me. I will reply to you as soon as possible. And so why it's become complicated? Because there is a synchronous manner. The synchronous implementation is a little bit difficult. Method. The method is also difficult, but you just focus on here, right? This method is more difficult. More important for us to use. There is a client key we should specify here. Here we can specify the IP and the port notification. Here you need to specify a key. The key is actually generate is a unique key to represent the local the client side. Usually it can be generated according to the combination of the IP and the port. Check idle, set idle checker. You must see that before, right? Because it's a I call it should be a monitor the threads on the line. So we need to set all to invoke the two methods. I think you'll feel it's a little bit confused or difficult to use so many to set up so many parameters and use so many methods. In the later classes, I will teach you a simplified approach. If you are just interested in implement application, you don't want to worry about so many underlying details. That's fine. I can give you a simplified approach to use grid free in the later classes. But for this time, because I want to teach as many details as possible, so I hope each developer or all the listeners know the essence of my system. So I list all the parameters and all the methods. But in the near future, for most developers, maybe it's not so important. But for some proficient, for some developers who want to implement a new system, in a complete distributed computing environment, those parameters is important. Those parameters are important, right? So okay, let's go ahead and let's take a look. Let us take a look at the real code. Here in this case, the chatting case, the sample code, we use a synchronous remote eventer to send a message. There is thread pool. Thread pool should be used. This thread pool is also an API I implement, and is the kernel of the system. The other thread pool is import from the Java. Yeah, Java have some thread pool we can use, but the interface is a little bit complex. So I design a new one that encapsulate the Java thread pool so that developer can use it more conveniently. But those similar to the free client pool, the thread pool is also not included in the distributed primitives. Because it's not just used to, it can be this one. Usually we use the thread pool can be used in any other cases, right? Not just for distributed computing. In some other cases, we also use this pool, and this pool is the thread pool is also a implementation. Not for just for distributed computing, so I do not list it here, right? It is not included in distributed primitives. Okay, here we need to, if you want to shut down or close the synchronous remote eventer, you can invoke the dispose method. Here we need to initialize, because there are a lot of parameters, so it spends some efforts. You need to specify all the parameters. It looks like a little bit complete. Here, you must see it before, right? On the server side, when the dispatch for the notification dispatcher, for the request dispatcher, we also detect whether the concurrency mechanism is ready or not. If it's not, we need to invoke it, because you can see here, this one is a thread, right? This thread is borrowed from the Java standard edition. So asynchronous remote eventer itself is also a thread. So we can, if this is not ready, it's also lazy initialization approach. It's used here again. Then we need to invoke it through the thread pool. And then we can send a message to the server asynchronously. Okay, the code looks a little bit difficult, but I think you don't need to worry. Yeah, I can provide you with a simplified approach to use them in the later classes. For proficient, I can just repeat. For proficient programmers, that should be useful. Yeah. Remote reader is another. The third one, the third API at the server side and at client side, it sends a request to the server first, and then it will wait there until a response is sent back from the server. So it's also important API, right? Because the notification and request are the two important messages that support any distributed system. So remote reader is an important API at the server and the client side. This is a class. The class looks simple, right? It's not a generic in this case. Constructor is also simple. No any parameters need to be used to be used to create any instance. Actually, itself is the remote eventer is a singleton. Let's take a look at real code later. Here is a read, right? We need to specify the IP address, the local key here, to use it. Okay, let's take a look at here. I can show you how to find it. Here is a package name, right? The package name is org.grapefree.client because it's client API. Here, double click it. Okay, you can see it, right? This is underlying implementation. Here is another API I implement. You don't need to worry about the implementation of this such API. We also need to manage the computing, the network-based input-output stream or computing resources for network programming. So here we can take a look how to use it. In this case, we can, for example, there are a lot of usages, reference, a lot of code uses one, right? Maybe we can take like this. Chat reader, right? Chat reader. This is singleton, right? You can see here, this is singleton. And if you want to initialize the remote reader, just invoke this method. Invoke this method. Oh, this method maybe I do not list it here, right? So the slides does not list all the methods. There's some other methods here, right? For example, the initial line. Okay, let's take a look at the real code. If you want to initialize here, you just specify the size of the pool, and then if you want to shut down, just invoke the method shut down. If you want to do some send a message to send the request, you can see here the IP. This is the local key, right? Local key. Each client have a unique key to represent the client. This key, you also may vary. You get confused why we need to specify this key. It's the reason we specify key here is to use to manage underlying resources. So if you don't like it, in the later cases, I will teach you how to use a simplified approach to use those API. So for preparation developers, yeah, maybe that's useful. But if you just want to implement high-level application, I will give you simplified approach to how to use it. Okay, read. Then a response is getted, right? Can be obtained. Here is another response. Request, response, right? Request, response. Okay, so it's easy to be used. So all the three clients at the client side, only three APIs are included. Server message. This is the API that transmit API that used to implement the message transmit between the client and the server. So I call it a server message. This is the root of message transmitted within Grapefree. We talked about that before. So all the messages should derive from server message. Itself is very simple. it should implement this API and this interface. Serializable. Serializable is a interface from the Java, right? So it's because the server message should be should be transmitted between the server over the network. So it should implement the serializable interface. Constructor. For the constructor, there are two constructors. The first one is type. Usually we just use one, is fine. Sometimes we use this one. There is a key should be specified. But in the most of the time, we just use the first constructor. This key, sometimes when we process some multicasting in the later cases, this key may be useful. At this time, if you are, because just to get started, when we use it, I will talk about this key. But at this time, you just leave there. You can ignore that and ignore it some temporarily. Get time, get key. This method is simple. The type represent the notification, right? The message. Each message have a integer to tell the server which method it received. The server identify the message according to the message type. Each message have a predefined integer to represent it, right? Because in the server side, in the later cases, I will show how to program on the server side. Then you know why we need to how to define such integer. Let us take a look at. We have already seen a lot of message. So first, let us take a look at the request. This is the first time for us to take a look at the message. First, let us take a look at how we can implement a message, a request. Open it. This is the message we call Paul new chat request. It should derive from the server message. This line is generated is required by the JDK. You don't need to worry about that. And then there's 3 fields here. Those fields and the data should be transmitted from the client to the server. So it's easy to be implemented, right? But different, little bit additional effort you need to do is to specify one integer to represent such request. It actually is it's an integer, right? I suggest you to use the integer a larger integer, not a small one. I think 109 is a little bit small. Yeah, because some small number integer are used by system message. So if you want to program with a grid free, you need to use a larger number. For example, 10,000, 20,000. Just like a larger integer is better, because if you use a small one, maybe sometime, for example, 10 or 11 or 12, those small number are used by underlying system. So I will tell you later. Yeah, you can understand. You can know how we can set such integer in the later programming classes. This is simple, right? To implement the message. This is the standard Java class to describe data, so it's easy to be used. This is this is a response, right? A request. We can take a look at the response. This is a counterpart of such a request I just say. So here, this is a response. Response is easy, right? Some messages are received, right? Some other classes is received. This is a chat message. This chat message is not a message. It's should be a class, a standard class implement that should implement serialization. Let's think like this. Right? Sometimes you need to transmit class, not just a string, right? Because here only for the request only string. This string is the original data from the Java JDK. So it can also be called primitive data. Primitive data, right? Primitive data type. Almost all the primitive type can be transmitted over the internet, over the network, without specify whether it should implement the serializable interface or not. However, if you want to transmit a class, a complete data structure, the self-designed data type, you need to implement serializable. But it is not server message. It's just a standard class that can be transmitted, can be persistent on the disk, can be transmitted over the network, right? So this is a standard class. This should be easy. If you understand, you have experience to program in Java, it's very easy for you to know about that. So here, some standard classes from Java should be transmitted over the network. It is saved in the list. And then the message should be implemented here, right? Then it can be transmitted using GridFree. So this class is easy, right? Next, we take a look at the notification. Maybe here. Notification, chat notification, right? We have also seen that before. Open it. Implement server message. No, not implement. Inherit the server message. And then all the data should be enclosed in the class. You can see here all the string, all the data type here is simple, just a string type, so it's easy to be transmitted. Here we need to specify the one integer, right? One integer. It's also easy to be implemented, right? So the message is very easy to be created. So just if you use server message. Okay, then all the fundamental distributed primitive APIs are presented, explained. Next time, we'll talk about some design pattern, code level design patterns in the next classes. Code level design patterns are discussed next time. So, although you know all the APIs, about 13, not about, only 13 API, distributed APIs. In GridFree, only 13 distributed So, but there are a lot of method and parameters how to use them. After a lot of work, based on all my experience, because I program a lot of code, based on those efforts, I discover, or I invent some new, some stable code structure. That is design pattern. That is design pattern I talk about. So based on the code stable structures, you can program with the APIs, using these 3 APIs conveniently. I should claim that all the distributed system can be programmed with those stable code structures or design patterns. Then that means GridFree is a generic. Just use those API. You don't need to use any other ones. There's some, I have made a lot of comparison in the previous class, but you can understand the details based on the programming. That's a better approach, right? So next time I will talk about some all the design patterns, how to program with the API. You don't need to just follow the APIs, but follow the design patterns. You don't need to invent any other ways to use such API. You just follow the stable code structure. If the code structure is repeatable, stable, that means it's convenient for you to program distributed system. Sometime, we can say that if the code the code structure is stable, then it's possible for us to generate code, right? So that's why a programming language can be proposed. Then if using the programming languages, the implementation of distributed system can be simplified again, right? Can be simplified further than the present approach, right? So that's what I want to do in the future research. So at this time, you have to use Java API. Java API is not so simplified, enough sufficiently. There are a lot of boilerplate code. Don't worry. I think according to the future classes, I'm trying to prove GridFree is a generic, self-contained. It may be the first one over the world. Okay, if you have any questions, just let me know. Thank you so much for today. Thank you so much.